Page 496, number 3 says copy the graph and add the sketch of the graph of each combined function to the same set of axes. So for A, we have f of x times g of x. So I've written the h of x function as 5 times 2x plus 3. So there's a few ways we can do this. We can do this first of all by just looking at the function and recognizing the type of function that we have. This ends up being a linear function with slope of 10 and a y-intercept of 15. So if I were to do that, I can just draw this on the set of axes. I can just draw this with a y-intercept of 15 and a slope of 10, and we can get that way. Now, I could also do this by just doing this with coordinates. So if I can just plot some coordinates, so take some key coordinates, for example, I'm going to take that 0. So at x is 2, negative 3. We have the y-coordinate of g is 0 times 5. That's going to give me a coordinate of 0. And I can do this for a few other coordinates here. So at negative 2, I have the y-coordinate of g is 1 times the y-coordinate of f is 5. So I'm going to end up with 5. I can do this for a couple other coordinates. Maybe at x is 0, I have 3 and 5. So that's going to be 15. So that's going to actually be a little bit off my graph. So what ends up happening is when I graph this is a linear function. I'm going to have a coordinate at negative 3, 0, negative 2, positive 5. Let's get rid of all these other markings here. And this is basically is a linear equation with slope of 10. So when I draw this in, I can draw it through those lines, and I can draw that through those points. Let's try that again. Okay, so I need a little bit better line than that, but I can draw that line through those points. So for B, I'm going to do this exact same thing. So I can take a look at B. I can write it in its rational form. So I should recognize that this is a rational function. My asymptote is going to be based on my denominator. So it should have an asymptote of negative 1.5. Okay, and it has a horizontal asymptote at 0. Now we could also do this using coordinates again. So if I actually just plug in some coordinates, for example, at x equals 0, I'm going to have 5 over 3 as my y coordinate. So at x equals 0, 5 over 3 is maybe somewhere around here. Okay, there's my coordinate. I can try one at negative 2. Okay, at x equals negative 2, when I plug that in, I'm going to end up with negative 4 plus 3 is negative 1, or y equals negative 5. So at negative 2, we're going to have a point down here. I can put a few more points in at x equals maybe 2, or let's just say 1. At x equals 1, y value is going to be 5 over 5, or 1. So 1 and 1 is going to be another point. And then based on my asymptotes and a few points I've graphed, I can put my graph through my rational function through those points. So it's going to follow the asymptotes and go through those coordinates. So the strategies I'm using here are I want to recognize a familiar function when I actually put the function together. I could also get x and y coordinates by actually just plugging in x's and y's into those two functions to get a table of values.